Hello everyone and welcome back. Today I want to talk about how you build a flow in a way that it can handle different circumstances, unexpected user activity, and also how to introduce error handling in a proper way. The goal if you build a flow should always be to build it with the thought in mind to make it as resilient as possible. What this means is that it should be able to handle different circumstances. For example, if connectivity to a source system is down, if the incoming message has an unexpected format, if some required information are missing, all sorts of things which are obviously related to the specific use case. But there is some general approaches which I would like to discuss today, which we have in our toolbox, which allow you to build the flow in a resilient way. Now, first of all, this is basically a flow that one of our customers has actually built. And what this does on a high level, it basically builds an API wrapper around the database. Instead of providing SQL-based access to database directly, the customer wants to build an API around the database so that external applications and clients can connect through that API in a secure way so that they have more control over what is going on. So I will first of all guide you through this flow step by step, and then we can dive into the details. Starting off with the HTTP listener, what this module does, it opens up an HTTP endpoint, as you see right here. So in this example, we are dealing with MES events. We define the format, the verb that we expect here, and that's more or less it. So pretty basic. Then moving on to the MS SQL executor. I use the executor because I want to execute a statement which might be a bit more complex. Here it's still kind of simple, but it could be way more complex in your scenario. So I just thought about using the executor right away. I have my credentials set it up in a way that the command timeout is set to 5 seconds on purpose. We will come back to that in a second. The target property is http.body. And in this statement, you see it's a pretty basic statement. I just select the top 2 entries from my database, and I reference a specific machine name from the incoming message. So I pick up the machine ID, which I want to get my events for, from the HTTP listener module. Once I get the results, I convert the result into a JSON object. Then I add the property mapper and add the status code on the property http.statuscode, in this case 200. And then in my HTTP response, I just reference the status code from the incoming message. I reference the body from my incoming message, and I manually edit the content type. So if we now connect this to a local node, this is the node on my laptop where it's also the SQL server is also running. Now I'm connected. Let me verify quickly if my SQL server is up. Yes. So let me move Postman into this picture. I guess most of you are familiar with this. So in Postman, I define just my URL. I don't have any security configured on my local node at the moment. Doesn't really matter for this setup. So I just specify the URL, the endpoint, and add the query parameter right here. Now I can start the flow. I have debug enabled on every module. So we should see some output soon. So if I execute this, you can see that I get my response here in Postman, currently for my device MC-002, and now I execute the same for 001, and there we go. You can see that we get the requested data. Now this is fine, and this is what you would expect if the user or the external application does everything in the absolute right way. Now let me clear up this debug, but let's think about what could go wrong in this flow. So starting on the left-hand side, we have the HTTP listener. This just receives messages, therefore we cannot really do much here. We just get whatever is sent in as the verb get, and that is being output to the next module. Now, on the next module, we can think about the first step of error handling. For example, what happens if the user or the external application does not add the machine ID as a parameter in the get command? So to simulate this and to show you what happens is, I just disable it in Postman, send it in again, and then we get just an empty response, which to the user then is a bit confusing. The user might expect that they just get everything now for all devices, for all machines, whatever that is, which is not the case. So the SQL response is basically empty, which means that also the response from the HTTP module is empty. Now, to kind of overcome this situation, there is a pretty nice module that you can use to verify that the parameters are available before we actually execute the database call. For those of you who are familiar with coding, if else is a pretty common approach for you. So we can add this module in between, and in here we can define conditions that we choose in order to route the message into different paths of the flow. So what I want to do here is I want to verify that the query parameter is actually in place. So this would be data.query.machine_id, and I want it to be existing. So basically I say it should not be null. So what happens now is we get the request from the HTTP listener. We have the if else module. If data query machine is not null, then we just execute the regular process, and else I want to have a different path. I actually want to notify the user that there is something missing. So if we don't have all the required parameters, then I want to return to the user that there is something missing. So what I do here is I use the message template and add just two properties in one object: status code and body. Obviously, feel to choose what we want to have here now. I just decided to go for setting in status code 500 and as body, which is what I will be sending back to the requesting client, bad request parameter machine ID is missing. Let's just assume this is the case. As target property, I want to set HTTP. So then I have, again, http.statuscode, http.body, which I then should be able to send into the HTTP response module. And therefore, I should have my first state of kind of error handling. So let's see. Let's run this flow again. So now let's first do the regular flow with all query parameters available. Works fine. It now chooses the if condition. And if I remove the machine ID, then I get the response back. Bad request, parameter machine ID missing, status code is 500. So that is now following the bottom path. So this is how you can at least ensure and also notify the requesting side that there is something missing here. Now that's the first step. And now let's dive a bit deeper into the flow. We've now reached the situation where we can verify that all the required parameters are available. And then let's move a bit forward and see what else could go wrong. Another common situation is if you try to call an external system. That external system might be, for example, not available, might not be responding in time, things like that. So a pretty common approach is to then use just a filter on the next module to only pass and process the message if crosser.success is true. You might know by now that every module generates a property crosser.success, which is either true if the operation was successful or false if it was not successful. So to show you what this means is the following. Let's start the flow again. I just show you the working example first. I just send in something and get back the events for my machine. But now I turn down my SQL server. My SQL server is just a Docker container in this case. I will turn this down, and then let's see what happens. So now my SQL server is down. Let me clear the debug output here, and let's execute the Postman call again. Now you see that we don't get a response as of now at all, because there is nothing that is being sent back in a proper way. Now, if we look at the flow, we see that there is a couple of things happening here right now. First of all, since the SQL server is down, we run into an execution timeout. So that is why I've set the execution timeout to just 5 seconds on purpose to show this. Default would be, I believe, 30 seconds. So we get the request, we verify that all data is there, but our database server is not responding in time, might be offline completely. This then generates the response with empty payload. And then basically you generate different types of warnings further down the flow. So this now would have generated at least one error and one warning, which is not really what we would like to have. Now, fortunately, there is a pretty simple way to overcome this situation, and this is by introducing message filters. What we want to do here is we want to make sure that we only process the data if the return of the SQL executor was successful. So what we say here is we say crosser.success equals true, and that's it. That's all we want to verify as of now. So if we do this, and let me start my SQL server again, and then we can run the flow. There we go, should be up and running and able to accept messages. Let me clear the notifications. So now if we run this again, working approach, and now if we turn down the database, let's clear this output again. Database is still being turned down. There we go. So we see the output of the HTTP listener, if else, and then the SQL executor fails. And what you don't see is any output of the JSON module, because it has recognized based on the filter that it should not process the message. So the message should be dropped. And therefore we don't generate any warnings further down the flow, which is good. But the problem now is that also my requesting client does not get any feedback. So what we could do is we should think about still notifying the client that there is something wrong with the database connectivity. Now, what we can do is we can follow a similar approach as we have already implemented here at the bottom with the message template. I will duplicate the message template, put it next to the JSON object, and here I set up the inverse condition. So if crosser.success is false, then I want to respond with status code. Let me see. Let's just use 400 here for a second. And then I can also reference the error message. So let's do this right here. And this I put into curly brackets. Actually, not too sure if I need the quotation marks, but we will see this in a moment. So let's see. If crosser.success is false, then this message template should be triggered. Let's call it database timeout just to be a bit more clear. And then we fire this out to the HTTP response. Okay, should be good. Let's see if that works. Starting the flow. Oh, that actually might. Yeah, good. There it is. So if we now use Postman again, my database is still down, but the request is fine. So let's see if we send this out. After 5 seconds, we should run into a timeout of the SQL executor. Perfect. And if everything goes well, yeah, it chooses the middle path, and we get the return failed to open SQL connection in an executor. So this is just a few ideas what you could do with your flow. Obviously, your setup might be way more complex. You might need additional filters in the if-else. You might have different modules. You might need different verification steps in between. But if you have implemented something, or if you have implemented the flow in a way that it can deal with different circumstances, situation based on if-else, split module, filters, and all that stuff, then you're usually at a pretty solid point. So I think that should be it for this session. Thank you for attending and hope to see you in the next one.